Hello everyone. So today we will be continuing on our final video of the integration series. So in this video I'll be talking about definite integrals, how to find the area through integration, and functions of the form e to the power of ax plus b. So let f of x equal to e to the power of x. So if we differentiate f of x, right, you would get e to the power of x. So then how would we integrate this? So integration is the opposite of differentiation, as you know. So by extending our definition of integration, we just do the step in reverse. So if you differentiate e to the power of x, you get e to the power of x. Therefore, if you integrate e to the power of x, you should get e to the power of x. Now let f of x equal to e to the power of 2x. Therefore, f dash x is equal to, so in this case, you bring down the power, the derivative of the power. So you take the power, you differentiate it, and then you multiply by the power of e. So then you would get, if you differentiate 2x, you get 2, so your answer becomes 2e to the power of 2x. So if you want to integrate 2e to the power of 2x, we basically do differentiation in the opposite way. So it's anti-differentiation. Therefore, above 2e to the power of 2x. So when we differentiated it, we multiplied e to the power of 2x by the derivative of its power. So in this time we have to divide by the derivative of the power. So we would have divided by 2, the derivative of 2x. So you get 2e to the power of 2x over 2, and that gives you e to the power of 2x. So that's how you integrate functions in that form. And always remember, put that plus c. Therefore, we can summarize this and say, if you have a function of the form, if f of x is equal to e to the power of ax plus b, if we integrate that, so the integral of f of x would be so you would have e to the power of ax plus b divided by the derivative of the power, which is ax plus b dash, and you get e to the power of ax plus b over a with the plus c. So that's how you integrate powers of e of the form e to the power of x plus b. Now let's talk about definite integrals. So what are definite integrals? So suppose we have a line, right? Let this be 2, and let it be y equals x plus 2. So if we have a point, let this be 4, and another point, let this be 2. So when we integrate, what we're actually doing is we're basically finding the area under this line. If you are integrating y equals x plus 2, that's what we are doing. So therefore, definite integrals occurs when we want to find the area between a specific range. So let's say between 2 and 4. So instead of you finding the entire area under the line, you just want to find the area under a specific interval. That's when definite integrals come into play. So this is how it would be notated. So you would have your your integral sign, and then your limits become the x coordinates, which is 4 and 2, and then the rest follows the same procedure. So dx. So this is the same thing. So we usually do it like how we integrate. So let's leave the bracket here. So if we're integrating x plus 2, we would have, so let's integrate x. So we have x, the power is 1, so we add 1 to the power, so 1 plus 1, and the new power becomes 2. So then we divide by the new power, and then plus 2, it's x to the power of 0, so you add 1 to the 0, you get 2x to the power of 1, and divided by 1, it's just 2x. So therefore you have 2x, and this gives you x squared over 2 plus 2x. And then we put our limits here, which is 4 and 2. You can notice how I haven't included the plus c. As we move on, I'll show you why we don't need to include it. So how would we integrate between the intervals? So if we put put 4 into the integral, so let's see, if we put 4 there, we will get 16 over 2 plus 8, which gives us 8 plus 8, which is 16. So this would, I'll just draw it here. So if we have this, let's say this is the graph, and this is 4. If we substitute 4 into the integral, it represents the area from this point onwards. Oh yeah, this goes on to infinity. So yeah, basically the entire area from less than 4. Now if you integrate from 2, so we have 2 there, then if we substitute 2, we would basically have the area from 2 to negative infinity, so it will go on like that. So therefore, if you want to integrate between the limits, we would have to find the area of 4 from 4 to negative infinity, 4 to negative infinity, and subtract the area from 2 to negative infinity to get the area between this interval. So we would only remain with just this, just that. So that's why when we integrate, we would substitute our values of 4. So we have 16 over 2 plus 8, and then we have to subtract by the lower limit, which in this case is 2, because we only want the area within that interval. So it's basically the area from 4 to negative infinity minus the 2 minus the area between 2 to negative infinity to just get the area between 4 and 2. So if you substitute 2 in this here, we get 4 over 2 plus 4, I think, yeah. So this becomes 16 minus 6, and answer becomes 10. So the reason why there's no plus c in this case is because like you don't need to include it. So I'll show you why. So let there be a plus c here. So the plus c is a constant. So even if you substitute 4 or 2, whatever, it will remain the same since it's a constant. So therefore, you would have your plus c here and your plus c there. So notice you have your plus c minus the plus c. So that means they cancel out. You can see them cancel out because of the negative sign. So that's why we don't need to include the plus c when we have definite integrals. We can just integrate what's between the brackets and we can ignore the plus c. So let me just do another example so we can be thorough with this. So let's have integral of x squared plus 3 from like 5 to 1. Okay, no, 5 is too big. Let's make it 3 to 1 dx. So this is what the graph would look like. So you have 3 there, and this is x squared plus 3. So if you want to find the area under from 3 to 1, so your 1 would be somewhere there. So you have your 1, and your 3 would be somewhere there. So 3. So this is the area you want to find. So let's do this. So we integrate what's there. So if we have x squared, so we have x, so you add 1 to the power, so you have 2 plus 1 divided by new power, which is 2 plus 1 is 3, plus 3. So since 3 is by itself, it just becomes 3x. And then you put your limits. So let me rewrite this. X cubed 3 plus 3x with 3 and 1 as the limits. So we substitute 3. So we have 3 cubed is 27. So 27 over 3 is 9. Minus 1 cubed is 1. So minus 1 over 3 plus 3 times 1, which is plus 3. So 27 over 3 is 9. 9 plus 9, 18. Minus 1 over 3 plus 3. So 3 is 9 over 3. So you get 10 over 3. And then this becomes 18 is 54 over 3. So 54 over 3 minus 10 over 3. And you get 44 over 3. That becomes this area. Now, let's look at a scenario like this. So let f of x equal to x squared minus 4. And we want to integrate from, we want to find the area from the 2 and 1. So this is how it should be. So let's see, let me sketch this. So you'd have that's there, minus 4 would be somewhere there, and there, and there. So this would be 2 minus 4, and 1 would be somewhere there. So now what the question is asking us is to integrate. So when we integrate, it's between the area we're finding is the area between the x-axis and the curve. So in this case, it should be this area. That's the area which we would be looking at. So therefore, let's see what we get if we integrate. So we integrate, we get x squared. So you have x to the power of, you add 1 to the power, 2 plus 1 divided by 2 plus 1, which is 3, minus 4, and it becomes 4x. 2 and 1 are your limits. Let me rewrite that. You get x cubed over 3 minus 4x 2 comma 1. And then you get, let's see, so we would substitute 2, we will get 8 over 3 minus 8. We substitute 1, so it's get 1 over 3 minus 4. So this becomes 8 over 3 minus 8, so that I think is minus 16 over 3, minus 1 over 3 minus 4, so that is minus 11 over 3. So minus and minus becomes plus, so minus 16 over 3 plus 11 over 3 gives you minus 5 over 3. But if you look at this, you can notice something. The sign is negative, and you can't have a negative area, right? So the reason why it's negative is because the area we're looking at is under the x-axis. So that's why it's negative. So if you're finding the area, all what you should do is you make this negative sign a positive sign, because area is a scalar quantity and it has to be positive. So what you can do is you can just put, like, you can just say after you get -5/3, get area is, you put a modulus sign, -5/3. So the modulus sign tells us we are only taking like the absolute value, which is 5/3, so it becomes positive. And that's how you would get your answer. So that's how definite integrals work. Since the video is already this long, I don't think I'll be able to go through any questions now, but if you guys do have any questions, feel free to email me. Here is, I'll put my email on in the comments, so you can you feel free to ask questions. I will be willing to answer them, and good luck with your exam tomorrow.